Hello everyone and welcome back to the Network Fixer, the channel where we simplify complex networking topics and help you master real-world IT. Today's session is going to be one of the most comprehensive and detailed deep dives you will ever find on DHCP. Whether you are a beginner trying to understand how networks assign IP addresses or an experienced engineer who wants to solidify your foundation, this video will give you absolute clarity. Over the next few minutes, we will explore DHCP from every angle: how it works, why enterprises depend on it, how to configure it, how to troubleshoot it, and how to design it for large-scale networks. By the end of this video, you will never look at IP addressing the same way again. DHCP stands for Dynamic Host Configuration Protocol. It is one of those silent heroes of the network, always working in the background, quietly assigning IP addresses to devices without anyone noticing. Imagine an organization with 2000 employees. If each device had to be configured manually with an IP, subnet mask, gateway, DNS server, lease duration, and other options, it would take days of manual work and also introduce endless human errors. DHCP automates all of this. When a new laptop joins the network, the user doesn't have to do anything. The moment they connect, DHCP instantly gives them an identity on the network. It decides which IP they should receive, how long they should keep it, and what gateway and DNS server they should use. This is why DHCP is essential in homes, offices, schools, data centers, cloud networks, and even IoT environments. Now let's talk about DORA, the art of DHCP. The entire DHCP process can be summarized into 4 packets: discover, offer, request, and acknowledge. Although it sounds simple, these 4 packets contain a lot of intelligence and negotiation. When a client joins the network, it has no IP address. It doesn't even know the DHCP server's address. So it broadcasts a message called DHCP Discover. This message basically says, "Hello, is there any DHCP server out there? I need an IP." The DHCP server receives the broadcast and replies with the DHCP offer. This offer contains the IP address the server is willing to assign, along with the subnet mask, gateway, DNS, and lease time. The client then sends a DHCP request, which is like saying, "Yes, I want the IP you offered. Please confirm it." Finally, the server responds with DHCP acknowledge, officially granting the IP lease. This entire process happens within milliseconds, yet it is crucial for seamless network operations. DHCP options are one of the most powerful parts of DHCP. They allow you to customize the network experience of each client. For example, option 3 tells the client which default gateway to use. Option 6 tells it which DNS servers to query. For VoIP phones, options like 150, 176, or 242 point them to their call managers. For PXE boot environments, options 66 and 67 define the TFTP server and boot file. These options transform DHCP from a simple IP assigning service into a full network provisioning system. A scope is essentially a pool of IP addresses that a DHCP server can assign. When you create a scope, you define the network address, the available range, the excluded address, and the duration for which clients can hold their IP. It's important to design scopes carefully. For example, you never want your DHCP scope to overlap with the static IP range used for servers and networking equipment. You also need to ensure the scope has enough IP addresses to handle peak load. Scopes must be clearly documented so IT teams know exactly which devices fall under each range. In enterprise environments, reservations are extremely useful. A reservation ties a specific MAC address to a specific IP address. This ensures that a device always receives the same IP even though DHCP is being used. Printers, Wi-Fi controllers, access points, firewalls, and certain servers often rely on reserved IPs. It gives you the convenience of DHCP with the predictability of static addressing. In modern networks, DHCP must be highly available. If your DHCP server goes down and you do not have a secondary or failover server, new devices will fail to get IP addresses. Users will be disconnected. IP phones will stop working. The impact is huge. To avoid this, DHCP allows two servers to operate in a failover relationship. They can load balance leases during normal operation and automatically take over if one server fails. This ensures that even if one site goes offline, the users can still obtain addresses without any downtime. Troubleshooting DHCP requires a mix of logical reasoning and packet level visibility. The first step is to check simple issues. Is the scope full? Is the DHCP service running? Is the client in the correct VLAN? If all basic checks are correct, packet captures become your best friend. Tools like Wireshark help you see exactly where the DORA process breaks. For example, if you see discover but no offer, the server never responded. If you see offer but no request, the client rejected the IP. Each scenario tells a story, and understanding that story is the key to solving DHCP issues quickly. DHCP fits into the application layer of the OSI model and uses UDP port number 67 and 68. Why enterprises must use DHCP? Because it saves time, avoids conflicts, central management, guest networks, large offices and VLANs, helps automation. The DHCP server can be created on a Windows server, Linux machine, a Cisco switch, firewall appliances, and the DHCP clients would be a laptop or a PC, mobile phone, printers, IP phones, etc. DHCP relay agent is very important in enterprise networks. IP helper address is used on the switches. So you might be thinking why relay is needed in VLAN environments. So without relay, clients cannot reach DHCP. The active leases are stored in DHCP database or DHCP bindings. If we go deep dive with the DORA process, the client will broadcast with the DHCP discover. It says I'm looking for a DHCP server. The server offers an IP which will be with the DHCP offer packet. Client requests the offered IP which comes with the DHCP request packet. Server confirms and assigns the IP which is with the DHCP acknowledged packet. So here are a few DHCP options. Option 1 would indicate subnet mask. Option 3 indicates default gateway. Option 6 is for DNS. Option 15 domain name. Option 42 NTP servers. Option 43 vendor specific. Option 60 Pixie client. Option 66 TFTP server. Option 67 boot file. Option 150 Cisco phones. Option 176 or 242 is for Avaya phones. DHCP options are used in IT environment, Wi-Fi onboarding, IP phones or VoIP infra, Pixie booting, imaging, VPN appliances, firewalls and Cisco controllers. Creating a DHCP scope is pretty straightforward, where we'll be defining a network, range, exclusions, leases, DNS and gateway. A few useful commands in DHCP troubleshooting would include ipconfig/release and ipconfig/renew. A few of the real-world IT incidents would include IP address conflicting, clients not getting IP address which may be due to VLAN mismatch, relay missing, DHCP service stopped, scope is full, wrong gateway, or rogue DHCP server. The other issues would be Pixie boot fails, it may be due to the option 66 or 67, firewall blocks. A next issue would include Wi-Fi clients getting wrong DHCP. This may be due to the misconfigured SSID VLAN, switch trunk issues. So another real-time issue that we have seen is printer losing its IP address. This may be due to the missing of DHCP reservation or it's a lease expiry. A few of the Windows troubleshooting commands would include ipconfig/all, ipconfig/release, ipconfig/renew. If you are in a Cisco environment, you can use commands like show IP DHCP binding, debug IP DHCP relay, debug IP DHCP server events. Thank you so much for watching this in-depth DHCP masterclass here on the Network Fixer. I hope you not only learned DHCP theory but also understood how it behaves in the real world and how to build reliable enterprise-ready DHCP infrastructure. If this video helped you, make sure to hit the like button, subscribe and turn on notifications so you don't miss the next big masterclass. Until then, keep learning, keep troubleshooting and keep fixing the network like a true network fixer. I will see you in the next video. Until then, take care of yourself. Bye bye.